Hello, welcome back to my YouTube channel. Our topic for today is kinematics. Kinematics, and our subtopic is what equation of motion. Equations of motion. Yes, equations of motion. Okay, so during our previous lesson, we talk about some of the terms concerning motion. We talk about acceleration. We talk about velocity. We talk about speed. We talk about retardation. We talk about average speed. We talk about a lot of terminologies in what? In motion, right? Today, we are coming to use those terms to derive the equations of motion. So you can visit the video about the terms in motion so that you get the concept well on that video. Then you can apply it here as well. Okay, so we are starting. Okay, so we learned that acceleration is the time rate of change of what? Of velocity. The definition for acceleration is that acceleration is the time rate of change of velocity. That's what we learned during our previous lesson, right? So, by definition of acceleration, acceleration is equal to change in velocity over time taken. Yes, because by definition of acceleration, acceleration is a time rate of change of velocity. Yes, so by definition of acceleration, acceleration is equal to change in velocity over time taken. That's the formula for what? Acceleration, right? Yes, so by definition of acceleration, acceleration is equal to change in velocity over time taken. Then you know that the symbol for acceleration is what? A, right? A is equal to, then change in velocity. Change in velocity. So I said in the previous video, v, you use v to represent final velocity and u to represent initial velocity over the time taken is what? T. Yes, so change in velocity when the car is in station or the car is at the station. When the car is at the station, it is stationary, so that its velocity is what? It's called initial velocity, right? 0 meter per second. Then when the car is moving, that one is what? Final velocity. So we have initial velocity where it started and where it what? Ended. So where it started is what? Is the initial velocity. Then where it will end is what? Is the what? The final velocity, right? So acceleration is equal to v minus u over t. V minus u over t. Yes, change in velocity. There's change in velocity. So for the velocity, change in velocity, you subtract the initial one from the final one. Yes, over what? Over t, which is what? The time taken. Yes, so that's the formula for acceleration. Then you got the formula for acceleration from the definition of acceleration as well, right? Yes. Okay, so now you can multiply here by t, here by t, right? So here you get at, right, is equal to, so you multiply t by both terms, you have two terms, so here you get at equal to, here to, if you multiply by t will cancel t, so you get v minus u, right? Yes, you get v minus u. Okay, so therefore v here is standing alone, right? It's standing where it is. V is standing where it is. So v is equal to u plus at. Because v here is standing where it is, then this u will move to this side. It become what? Positive, right? Yes. So we get u plus at. So I just wrote it proper here. V is equal to what? U plus at. U plus 80. If you make v the subject, you get v is equal to u plus what? 80. Because this one will move to here, become positive. Yes. So this is the first equation of motion. Yes, the equations of motion. This is the first one, right? And where did we get it from? We're able to get it from what? From the equations of what? We're able to get it from what? From the definition of what? Acceleration, right? Yes, we got the first equation from the definition of acceleration. Acceleration is the time rate of change of what? Of velocity. So acceleration is equal to change in velocity over time taken. Yes. So A is equal to v, that the final velocity minus initial velocity over t, which is the time, right? Yes. Then you make v the subject. You're able to get the first equation of motion. Able to get the first equation of motion, right? Okay. Now, average velocity is equal to total displacement over total time taken. Yes, during our previous lesson we learned about average velocity, right? Yes, and we say that is the total displacement over total time taken. Yes, so the length that you took to reach a certain event or a certain place over the total time that you spent to get to that place. Yes, so average velocity is equal to total displacement over total time taken. Displacement. So displacement talking about where the length, maybe you are at the school foot and ask you to go to administration. The length, maybe you use 200 meters to get there. That's the displacement over the total time taken. The time you're able to use it to get there, right? So average velocity is equal to total displacement over total time taken, right? Okay. So average velocity is equal to what? S over t. We use S to represent displacement, and we use what? T to represent what? Time. So average velocity is equal to what? X over t, right? Yes, that's equation A. That's equation A. Yes. So for a body moving with a constant acceleration, then average velocity is equal to v plus u over 2, right? Yes. So for a body moving with a constant acceleration, the average velocity is equal to v plus u over 2. So for that one, you add the initial velocity to the what? To the final velocity, and you divide by what? By 2. So average velocity can also be represented as what? V plus u over 2, right? Yes. So we represent that equation as what? As B as well. Represent that equation as B as well. Okay, so now from equation A and B, so from equation A is what? X over t, right? Equal to equation B is what? V plus u over what? Over 2. Yes, you can equate them because they are all the same, right? Because this one is average velocity, this one too is what? Average velocity. So now from equation A and B, which all talks about average velocity, you can equate them. Yes, you can equate them. So you get S over t is equal to V plus u over what? Over 2. So now we can multiply both terms by t, right? So if you multiply here by t, yes, so if you multiply this term by t will cancel t, so it here will be left with what? S, right? Now you get v plus u over 2, then multiply that one by what? By t as well, right? Because you multiply both terms by t, here by t, here by t, here the t will cancel t, so it will be left with s equal to v plus u over 2 multiplying with t, right? Okay, now from equation 1, if you make t the subject, right? From equation 1, if you make t the subject, you get t is equal to, because u move from here to become v minus u over what? T. From equation 1, if you make t the subject, you get t is equal to v minus u over a, right? Over a. Yes. So from equation 1, if you make t the subject, you get v minus u over a. Yes, so this is equation 1. So this one will move to here. So v minus u over, then you divide by a, both side by a, both side by a. You get what? That one. Okay. Now, so we can substitute the t into equation what? C, right? Yes. So wherever you see t, you put v minus u over a there, right? So now see, you have s is equal to v plus u over 2. Then wherever you see t, we are replacing what? V minus u over what? Over a, right? Yes. Okay. So s is equal to, you are multiplying v plus u by v minus u. This is what? Difference of 2 squares. So you get v square minus what? U square. Yes. A difference of 2 square. You get v square minus 2 square. Then that one, 2 multiplying a, you get what? 2a. You get 2a, right? Okay. Now you can cross both term by 2a, right? So if you multiply here by 2a, you get 2as equal to, you multiply here by 2a, 2a will cancel 2a, so you get v square minus u square, right? Yes, v square minus u square. Now you want to make v square the subject, so we get v square is equal to what? U square plus 2as, because when this one comes in what? Positive, right? Yes. So v square is equal to what? U square plus 2ax. So that is the second equation of what? Motion. That's the second equation of what? Motion. You're supposed to pay much attention, because what I'm doing is an examinable question, right? You can be asked to prove the formulas. Yes. Okay. So v square is equal to 2, v square is equal to u square plus 2as. That's the second equation of what? Of motion. So now you see from equation 1, right? From equation 1 is v is equal to u plus at, right? That's from equation 1. You say substituting equation 1 into equation 1 into c. Substitute equation 1 to c, and you know that c is equal to what? S is equal to u plus u over 2 t. So wherever you see v, you put u plus at there, right? Wherever you see v, you put u plus at there, right? Okay. Yes. So we have able to substitute equation 1 into the what? Into c, right? Yes. So x is equal to u plus 80. Here was v, but you have replaced v with u plus what? 80. Plus u over 2 multiplying t. Okay, so now x is equal to what? U plus u, you get 2u plus 80 over 2 multiplying time, right? Okay, so now s is equal to 2u, t will multiply all of them, so it will multiply the top one, so 2ut plus at square, a t multiplying 80, you get 80 square, right, over 2. So now s is equal to, so now you get 2 ut over 2, right? Because it is by that one. Then a t square over 2. So therefore s is equal to ut plus half at square. Yes. So watch it carefully. So that's what you get. Then these two is dividing both this one and this one, right? Yes. So after that, you use it for this one only, you use it for this one only as well. So 2 cancel 2, so you get ut, right? Then equal to 1 is in front of this one, but you don't write it, so half 80 square, half 80 square. So this is the third equation of what? of motion. This is the third equation of motion, right? So now the equations of motion are, then you write them. So the first one is equal to what? V equal to u plus at. The second one is equal to what? V square is equal to what? U square plus 2as, right? And the third one is equal to x is equal to ut plus half at square, right? So these are the what? Equations of what? Motion. These are the equations of motion. So whenever you have been asked to prove them, you're supposed to what? Do them accordingly. So now I'm going to show you from equation 1, equation 2, equation 3 how we did it, right? So we started from here where we talk about acceleration. You're able to get the first equation of motion. We're able to get the first equation of motion from the definition of what? Acceleration, change in velocity over time taken. So A equals to V minus U over T, right? Then we can in the subject, you're able to get the first equation of motion. Then we came to average velocity, total displacement over total time taken. So average velocity is equal to S over T. And for the body moving with a constant acceleration as well, average velocity is equal to V plus U over 2. Now you have gotten to average velocity, right? A and B. Then now you do what? You equate them. Yeah, so you equate them. So S over T is equal to V plus U over 2, right? Yes, then making S the subject, you get a multiple by T. So S equal to V plus U over 2, right? Multiplying T. Okay. Then from equation 1, making T the subject from the equation, which is this one, you got T is equal to V minus U over A, right? Yes. Then S is equal to V plus U over 2, multiplying wherever you see T, you replace it with this one, right? Then the top one is difference of 2 square. So S is equal to V square minus U square over 2A. If you multiply the difference of 2 square, that's what you are going to get. Okay, now making V square the subject, you multiply both sides by 2A. So here be 2as equal to 2a comes 2a, so you get the top one only. Then making V square the subject, you're able to get V square is equal to U square plus 2as, right? That's the second equation of what? Of motion. So for the assignment, we are doing question 48b. Yes, we are doing this question 48b. You see, show that the displacement s of a body moving with a uniform acceleration a is given by s equal to ut plus half at squared, where u is the velocity of the body at time t equal to 0. Yes, so what the question is telling us is that you should prove that formula, right? You should prove, or you should show that s is equal to ut plus half at squared. Yes, so show that displacement of s of a body. Yes, so you do it and you send it to me, multiply with 3, right? You watch the video or you join the lesson. After that, you do the work independently. Don't copy anything. Yes, because you know that the first equation of motion from the acceleration and the second equation from the average velocity. Now the third equation is from the equation 1, which you substitute into the equation C. Yes, so you have to do this work and you send it to me privately, right? Yes, prove that formula. How were you able to get that formula? Prove it. So it is an examinable question. Make sure that you really understand it. Okay.